Okay, what I'm going to do is, sorry, there's a lot of writing on here, so let me just start what we're doing. Okay, this is what we talked about in class today. So, and I'm going to take it a little bit further. This is the detailed explanation. So, we want to find out about this integral. Well, that's equal to the sum by definition. And we showed that this sum was equal to g of b minus g of a, where g prime was f of x, and x naught was a, and xn was b. So this is what I kind of indicate. I didn't say I proved it in class. I showed you. I gave you an explanation. And I want to go into a little bit more detail today. So what we did is we used this right here. Since that's true, why don't we just write our integral this way, and then just makes it more straightforward. We can deal with this sum. And what we showed in class was that this was equal to the net change, which we said was g of b minus g of a. Again, I'll review this. Now, the key idea is the derivative. G prime of x is equal to this. This is our definition, g of x plus delta x minus g of x. So we identified this as delta g. Sorry for the cross out. And by identifying that as delta g, we can write the derivative like this. And that was very useful. So, but I want to do something a little bit different. Remember, we have all these x1s, x0s, and such kicking around. So, in other words, these are all where we draw the rectangles. Okay. Now, remembering that the difference between each of these is delta x, and let's use a uniform delta x, because it makes life easier. What we get with that is that if I look at x plus delta x, and if we use as our x's are these xk's, so xk minus 1, then we get x plus delta x is xk minus 1 plus delta x, which is equal to xk. So just this idea we talked about before the exam right here. If we're at xk minus 1, we move our delta x, we get to xk. That's all I'm saying right here, but this is important, and we'll come back to it. Okay, so now I'm going to go over what we did in class. So we have integral g prime x dx a b equaling the limit of this sum and I'm going to use x k equals ck minus 1, and delta x is uniform. So we wrote this way. These canceled, and we get to the limit of a sum of all the dg on the interval a to b, which is the net change, on a minus b, which is g of b minus g of a. Okay, so this is what we did. This is what we did in class. Now, I'm going to take this a little bit further. I'm going to go back, and we saw before that when we looked at delta g, that was g of x plus delta x minus g of x. We're going to use this as so what I'm doing here is, as we did in front, I'm going to let x equal xk minus 1. Then we saw this is really g of xk minus g of xk minus 1. So this is what my delta g is. So I'm going to substitute this right into here. And I think something really cool happens. Delta G is equal to this. That's my delta G. So what do I get? When k is equal to 1, I get g of x1 minus g of x0. When k is equal to 2, I get g of x2 minus g of x1. Note what's going to happen. Here, I'm going to block this off. When k is equal to 3, I get g of x3 minus g of x2, and I keep going, and I get g of xk minus 1 minus g of xk minus 2, and the last one. So when k is equal to n, I get g of xk minus g of xk minus 1. So basically, I'm taking this right here, and this is going to be equal this limit. And what happens here? Well, this and this cancel. Well, this and this cancel. Well, there's going to be one over here. That's going to cancel. Okay, now if you notice, this and this cancel. So this is going to cancel with something there. So all these terms cancel. And this is what I'm left with. G of xn, right here, minus this one. So this is left, and that's left. G of b minus g of a. So this is close to how the real proof works. Start here. We write this as a sum of the derivative. Make this we rewrite g prime of x as delta g over delta x. Get that? Then we write out this as delta g is really g of xk minus g of xk minus 1, which we showed over here. Now I unwind this sum, and this is what I get. And you get what's called a telescoping sum, because you get this long sum like this, and it ends up very close, kind of like an old-fashioned telescope. This first term cancels here. The second term cancels here. And you keep going. This third term is going to cancel over here, and so forth. All you're left with is this term and this term, which I'm indicating here, g of b minus g of a. So again, to really prove this right, there's a lot of real fine details which really are beyond this course. You would do that in a course called Real Analysis. Okay, do you need to know this? Yeah, I think you should be able to understand how you go from here to here to here and how it cancels out. It's something I can talk more about. Thanks a lot.